There's good news and bad news here. The good news is it's not as bad as you might think. The bad news is it's worse than you'd like it to be. So let's start with another property. So if that q of x, right, that polynomial on the denominator has a repeated factor, ax plus b with multiplicity n. Remember what multiplicity means? If it has a factor of multiplicity n, that means when you factor it, that factor has an exponent. And that exponent will be n. Then that tells us that p of x over q of x equals some constant divided by that factor. So this should be looking pretty familiar. Plus another constant divided by that same factor squared. Plus a bunch more constants. And then the last one will be that same factor. So this is another form for partial fraction decompositions. If the factors are distinct, then it's just the constants over each factor. If they're not distinct, then it's a constant over just all the different exponents of that factor. And you can combine these two things too. If it has some distinct factors and some repeated factors, you can combine them. We'll talk more about that in the 6th video. Okay, so this is this. Let's do it. Example 4, let's look at the integral of x minus 2 over 2x minus 1 squared times x minus 1. Okay, before partial fractions, think of the tools that we've got here. Will u substitution work? Almost. No, not quite. No, not almost. No, u substitution is not going to work here. Okay. Integration by parts. I don't see any trig subs or trig integrals, or I don't see anything. This is just a straight up rational that looks pretty boring. Oh, can we divide it out? No, the degree on the top's not big enough. If the degree on the top were a 3rd degree or higher, then yeah, we could divide it out. So we're going to have to use partial fractions. So let's look at this. Partial fractions, I don't know why I'm writing in a different color. Partial fraction says, okay, we have one repeated factor and then a distinct factor. So let's combine the two methods that we've talked about. We don't even have to factor it. They did it for us. So nice. It's going to be some constant divided by that first linear factor plus another constant divided by that first linear factor squared, right? That's what it was for repeated factors. You do it constant over the factor by itself, and then another constant with the factor squared. And if it were cubed, then you'd have a 3rd term as well. But it's only twice, so we only have 2. Also have to take care of this distinct factor as well. So that'll be that 3rd c of x minus 1. Okay, this is where the jacket's coming off, because this is where we got to get into things. Okay, so we can multiply both sides of this equation by the LCD. I'm not going to bother writing it out. That'll give us a times 2x minus 1, because one of them will cancel, times x minus 1. I probably should have written it out. Plus b. All right, let's write it out. All right, we're multiplying both sides of this equation by 2x minus 1 squared times x minus 1, the LCD. Okay, when we distribute, this first guy, one of the 2x minus 1 squareds cancel. The second one, both of them cancel, and we just have the x minus 1. And on the last one, the x minus 1's cancel, and we just have the 2x minus 1 squared. Now we need to either equate coefficients, which will always work, or we strategically substitute. Let's strategically substitute. Okay. So what happens if x is equal to this guy? If this guy is equal to 0, 2x is 1, x is 1/2. Well, if x is equal to 1/2, we get 1/2 minus 2, so that's 1/2 minus 4/2, is equal to, if x is 1/2, this guy is 0, plus b times 1/2 minus 1, plus, oh, this last guy is equal to 0. This is great. 1/2 minus 4/2 is negative 3/2, equal to negative b over 2. Multiply both sides by negative 2, you'll get b is equal to 3. Great. Okay, well, now let's plug in x equals 1. Let's actually copy it. I never write straight, so this doesn't work like I want it to. All right. Oh, for crying out loud. There we go. I mean, they have lined paper, right? I should just use the lined paper, but I don't like lined paper. In fact, even in my own scratch work for my own math, it's just blank printer paper. So let's also plug in x equals 1. When you plug in x equals 1, we get 1 minus 2 equals, this guy is a 0, this guy is a 0. And this becomes c times when x is 1, becomes 1 squared. Oh, great. So c is negative 1. All right, what else should we plug in to get the last one? What else are we plugging in? Well, we plugged in so that this factor was 0. We plugged in when this factor is equal to 0, but there's only 2 distinct factors here. So what do? We have to equate coefficients now. All right, so let's plug in a and b, and let's see what happens. Hey. Okay, so we know c is negative 1 and b is 3. So that gives us x minus 2 equals a. Yes, we're going to have to FOIL. Let's see if I can do the foiling this time. 2x squared minus 2x minus 1x is minus 3x. This becomes a plus 1. Plus b, which is 3. Plus c, which is a minus 1. 4x squared minus 4x plus 1. All right. Keep it going. Let's keep simplifying. X minus 2 is, well, actually, we don't have to keep going. We could stop right now and equate coefficients now. We could equate the x squared coefficients, is probably the easiest. Because, or maybe it's not the easiest. It looks the easiest to me because there's not that many of them. There's no x squareds on the left. There's 2a x squareds here. There's no x squareds here. And there's a minus 4x squareds over here. Oh, okay. 2a is 4. A equals 2. So, where does that bring us? That brings us this integral. Dang, I keep on adding extra pages I don't need. The integral of x minus 2 over 2x minus 1 squared x minus 1 dx is just equal to, now we have room, the integral of a, which is 2, over the first factor, plus b, which is 3, over the first factor squared, plus c, which is negative 1, over the last factor. There we go. Now, of course, we're going to check our answers because algebra is hard. And again, you could the real way to check your answer is to just combine fractions. The fast way to check your answer is like this. X minus 2 divided by 2x minus 1 squared times x minus 1. I got so excited. I was like, look, they're the same graph, but I've only typed in 1. Okay. 2 over 2x minus 1 plus 3 over 2x minus 1 squared minus 1 over x minus 1. Thank goodness. There's a lot of ways to make mistakes on these, but all right, great. Looking good. And you could have done this with equating coefficients and done that system of equations with 3 equations. It's painful, but it's possible. Painful, but possible. Maybe I'll do that at the end of this one just for fun. Just for some more math. You know, I probably will. Let's go. All right, so this first integral, this is where, all right, let's be very careful here. I want to show good habits. This is going to be 2 times the integral of 1 over 2x minus 1 dx plus 3 times the integral of 1 over 2x minus 1 squared dx minus 1, I'm not going to write that, integral of 1 over x minus 1 dx. So 3 u substitutions. This first one, u is 2x minus 1. So du is 2 dx. So we need a 2 here. We have to compensate. And we're going to get 1 times the integral of 1 over u du. The second one, u is, again, 2x minus x. I guess we can use u1 again. It's the same u. So du is going to be 2 dx. That's going to be, oh, we don't have a 2 dx. Need a 2. Got to compensate. We get 3 halves integral of 1 over u squared du. And again, it's the same u, so we can call it u1 again. And the last one, though, is a different u. U is going to be x minus 1. So du is dx. Oh, that one's easy. 1 over u2 du2. And again, it really matters that you're using different u's here. Otherwise, when you get rid of the u's, you might get rid of them with the wrong stuff. This becomes the natural log of the absolute value of our first u plus 3 halves. Oh, this is u. Be careful here. Right, this is u2. Sorry, u1. Oh my goodness. This is u1 to the negative 2. We don't use natural logs anymore. Do not use natural logs on this. That's only if the power is 1 in the denominator. So this is the power rule. We add an exponent and divide by that new exponent. Oh, so this turns negative. And then minus the last guy, the natural log of the absolute value of u2 plus c. Now our first u was 2x minus 1. Our second u, oh, it's still our first u, 2x minus 1. And then minus the natural log of, like this. I can't speak, but I can write. And again, we could check our answers, and we could do lots of things to do this. All right, I'm confident though. We're going to end the video. Bye-bye. Good luck. Enjoy.